All right, question 20. Those of you who haven't seen it, you have 30 to 40 seconds to have a look at it before I start picking on you. I don't need an answer. 40 seconds, you better have a game plan. Okay, what is this question actually testing, everyone? So Maya, you see this question in your exam. What am I testing here?
Mitosis? Wait,
Oh,
meiosis?
yeah, meiosis, right? But more specific, what am I testing here? Micah.
Like how different alleles combine.
Still a bit vague. Raiden, what am I testing here?
Your knowledge of random segregation.
Yes, that's what I want to hear, right? Because if you don't know what the question's testing, you don't know what to say to get the most marks, and you don't know how to plan your answer. So right now, your head in this huge expanse of HSC biology should narrow down into thinking about meiosis and should narrow down to thinking about random segregation and independent assortment. The way I know this and the way Raiden mentioned it is because it's saying assume that crossing over does not occur. Now, if crossing over did occur, what can happen is any of these alleles on homologous chromosomes can interchange. But now we know that can't happen, right? And this is where you have little thought experiments in your head, right? There's going to be 4 gametes formed in this process, right? What's going to happen within a homologous pair? Bilal, within a homologous pair, what process occurs?
Mitosis?
No. Within a homologous pair, mitosis, we're talking about random segregation and
Random segregation. It will be random segregation.
Yes, right. Remember, mitosis is a completely different process,
Yes.
right? You're on a different page then. So we're talking about random segregation here. So if this chromosome goes to the left, this must goes to the right. So they must go to opposite ends. And the same applies here. This chromosome can go to the right, has a 50 chance of going in that respect, left or right. And this chromosome has an equally likely chance. Now, what this means in letter sense is that all we need to have is a combination of one of these chromosomes and one of these chromosomes. That will make up the organism's genotype. We all agree, right? Because the organism is inheriting one big chromosome, one small chromosome. Okay, so let's go through this. What do we have here? So let's start with option A. Sean, what do you think about option A? AB little c. Can an organism inherit AB little c?
No.
So apologies, I didn't clarify. Capital A, capital B, little c. Can it inherit that?
Oh, wait.
Do you see a chromosome which has capital A, capital B, little c?
Yes, yes.
Yes.
Okay, good, right? So the answer is yes. What about here? Yes or no? Maya, your turn. How about the D and E? What do you think about that, Maya? So you see a capital D and capital E. Can we inherit a capital D with a capital E?
No.
No, because if you have a capital D, you must have been inheriting this chromosome, and unless crossing over occurred, a capital E could not have jumped across. Do we all understand that? Right? This is actually quite a simple question. So A is out of the question. Have a look at B. Can someone tell me why B might not be right or why it might be right? A couple seconds to have a look at it. Go through the same thought process. Since crossing over did not occur, this organism is going to get one large chromosome, one small chromosome. You can't violate that rule. And if these combinations work out, Raiden, why do they not work out?
Because for the first one, a lowercase b can't jump over to the first one.
Yeah, you see capital A, little b, and a capital C. Capital A, little b makes sense. It's on the same chromosome. Yeah, capital A and little b, but you see a capital C, that makes sense. So capital A, capital B, capital C doesn't make sense because that capital C must have broken off, right? And we've clearly said crossing over does not occur. So B is not right. Alec, what do you think about C? Go through the same thought process. See, this question, a kindy student can answer it. What the hard part about this question was understanding what the question was asking. And all you need to realize is you can only pick one big chromosome, one small chromosome. You can pick any combination you'd like. So Alec, what do you think about option C? Does this work out? Capital A, little b, little c. Capital A, Alec. Little b. Can you have a little c, Alec?
I'm pretty sure his audio doesn't work.
Oh no. Okay. Who can I ask? Bilal. Back
No,
to
it
you.
doesn't work.
No, it doesn't, right? So we cancelled all three out. Test this one, everyone. Does that work out?
I think it does.
It does.
Yeah, it does.
Tick. That's your answer. Not too hard, right?